Hey guys, I'm just gonna make a quick little video here about the transition metal exceptions in electron configuration, chromium and copper. Okay, now just a heads up, if this is not a very good job, it's because this is something that I just had trouble with, and that's why I said, well, I think I gotta do this. But that also might mean that I don't do a great job. Okay, whatever. Let me just get right into it, okay? So, first of all, I'd also like to teach, this is maybe a side thing, a separate thing, I'd like to teach this thing called Nobel Gas notation, okay? So for example, to start off, it's like, okay, here's how you'd write argon. You know, argon here. You go 1s2, 2s2, 2p6, 3s2, 3p6. Geez, that's a lot. That's a lot of writing. Okay, krypton. I just said krypton. Potassium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s. What's like, jeez, that's a lot of writing. Titanium. This is, by the way, a skip. You know, calcium was the next one. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. That is just so inefficient. And if you look at this, it's like, why do we need to clarify that all this stuff is here? It's like, we get it. We know it's here. Potassium and titanium come after argon. So why do we have to write this nonsense every single time? Well, that's what Nobel gas notation is about. What you do is, noble gas is, because noble gas is at the end of a given shell, that's a good stopping point for, you say, okay, what, you're here? Okay, well, let's just say everything that comes before that and however far you are in the next shell that isn't complete. So for example, well, okay, first of all, argon, you just write as this. But then how would you write this? What you'd say is, you say, okay, well, what's our nearest noble gas going back? Argon. Okay, then how far are we from that? How far are we after that? Oh, 4s1. Hey, that's good stuff. What about titanium? Geez, that's so much better, and that took me about 1/100th as long. That's how it feels, at least. Yeah, and you can do that with all of this. You know, scandium would be argon 4s2 3d1. You know, that's easy. And that's important because on the next side of the sheet, that's the notation I'm going to be using. Okay. Next, I want to use this little thing. I don't remember if we talked about it, but it kind of helps me to understand the order that it's supposed to go, because that turns out kind of weird. It's like this, okay, 1s. This is the 1s thing. This is 2s. This is 2p. Okay, good. Makes sense. 3s, 3p. Good stuff. 4s, and this is 40. No, it's 3. It's 3D, and that just kind of, it's not that complicated, but I don't know. It might be a little confusing. All you have to do is memorize, but I don't know. The thing is, with this thing, what's cool is you go like this. This is the order. You go diagonal like this. Look, see? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. Okay, that's the next one. And the next one after that would be 4p6. That's obvious. You know, you go 4p6 here. It's not that complicated. All you have to do is just know that this is, we decide to call this 3d. And not just decide. It's like, there's a good reason. It has to do with energy levels. But I don't know how to talk about that. But yeah, that's the information now. Now I'm going to move on. Okay, so here we've got transition metal electron configurations, the expected ones. And as it turns out, the expected ones for all except chromium and copper are the way that it is, but chromium and copper are the exceptions. We're going to talk about that. Okay, so this guy, it's like, yeah, okay, so he's this far. So 4s2, 3d1 is how you anticipate it, and then it actually is true. Titanium, saying they just, but apparently there's some deal with how this is actually a lower energy level than this, even though this comes first with elements, but we're not going to talk about that. Vanadium, 4s2, 1, 2, 3, 3d3, okay? And then you get to chromium. And you'd expect it to be like this. You'd expect it to have its 4s shell filled. And look at this. It's like so perfect. It's like, okay, you're just adding 1 to the 4d every time. That's what you expect it to be like. But as it turns out, no. You get this situation. You only have, let me just, one of these guys disappears, right? One of these guys disappears. You only have